Okay, hi everyone and welcome to this live stream for Windows Server 2003. So I want to share my screen. Okay, monitoring overall activity. The server status node in the RRAS snap-in shows you a summary of all RRAS servers known to the system, depending on whether or not you use the features discussed in Chapter 9, managing IP routing. To manage multiple RRAS servers from one console, you may only see the local server's information here. When you select the server status item, the right-hand pane of the MMC will list each known RRAS server. Each entry in the list tells you whether the server is up or not, what kind of server it is, how many ports it has, how many ports are currently in use, and how long the server's been up. You can right-click any Windows Server 2003 RRAS server in this view to start, stop, restart, pause, or resume its RRAS service. Disable RRAS on the server or remove the server's advertisement from Active Directory, provided of course that you're using AD, which means Active Directory. Controlling remote access logging. A standard RRAS installation will always log some data locally, but that's pretty useless unless you know what gets logged and where it goes. Each RRAS server on your network has its own set of logs, which you manage through the remote access logging folder. Within that folder, you'll normally see a single item labeled local file, which is the log file stored on that particular server. If you don't have Windows accounting or Windows authentication turned on, you won't have a local log file. Depending on whether or not you're using Radius accounting and logging, you may see additional entries. However, the following sections will stick with local file logging. Setting server logging properties. The first place from which you can control server logging is at the server level. You use the logging tab to control what level of detail you want in the server's event log. It should be noted that these controls regulate all logging by RRAS, not just remote access log entries. You have 4 choices for the level of logged details. The log error only radio button instructs the server to log errors and nothing else. This gives you adequate indication of problems after they happen, but it doesn't point out potential problems noted by warning messages. The log errors and warnings radio button is a default choice. This forces the server to log error and warning messages to the event log, giving you a nice balance between information content and log volume. The log all events radio button causes the RRAS service to log mass quantities of messages, covering literally everything the server does. While this voluminous output is useful for troubleshooting or for getting a better understanding of how remote access works, it's overkill for everyday use. The do not log any events radio button turns off all event logging for RRAS. So here you can see figure 7.11, the logging tab of the server properties dialog box. The log additional routing and remote access information checkbox allows you to turn on logging of all PPP negotiations and connections. This can provide valuable information when you're trying to figure out what's wrong, but it adds a lot of unnecessary bulk to your log files. Don't turn it on unless you're trying to pin down a problem. Setting log file properties. You can select an individual log file in the snap-in to control what that log file contains. More precisely, you can control what events should be logged in that file from the time of the properties. Logged in that file from the time of the change forward. You make these changes by selecting the log file and selecting Action, properties or selecting properties from the pop-up menu, to open the log file properties dialog box. This dialog box has two tabs. The settings tab controls what gets logged in the file, and the local file tab controls the format of the file itself. The setting tab of the local file properties dialog box, so you can see that in figure 712. Figure 713, the log file tab of the local file properties dialog box. So the settings tab has three checkboxes that control what gets logged. Accounting requests governs whether events related to the accounting service itself will be logged, as well as accounting data. This should always be checked. Authentication requests adjusts whether successful and failed log on requests are logged or not. This too should always be checked. Periodic status controls whether or not interim accounting packets are permanently closed on disk. This should normally be unchecked. The log file tab controls how the log file is written to disk. You use this tab to designate three things. The directory field shows where the log files stored by default. Each server logs its data in the system root /system32 /log files /iaslog.log. By using the log file directory field, you can change this location to whatever you want. The format controls determine the format of the log file. By default, RRAS will use the older Internet Authentication Service IAS format, which was originally used by the IAS component included as a part of the Windows NT option pack. You can instead choose to use the database compatible file format, which is only available in Windows 2000 and Server 2003. This format makes it easy for you to take log data and store it in a database, enabling more sophisticated post-processing for things like billing and chargebacks. To create a new log file, controls determine how often new logs files are created. For example, some administrators prefer to get a new log file each week or each month, whereas others are content to get the log file grow without end. You can choose to have RRAS start new log files each day, each week, each month, or when the log file reaches a certain size. So I'm just going to skip this. Reviewing the remote access event log. You can use the log file tab to find out exactly where the log file lives, but what do you do with the log information then? Windows Server 2003 Online Help has an exhaustive list of all the fields logged for each connection attempt and accounting record. You don't have to have all the fields memorized, and you don't have to know how to make sense of the log entries. The support tools on the Windows Server 2003 CD includes a handy utility called IASparse that will digest an RRAS log in IAS or database format and then produce a readable summary. Why bother reviewing the logs? One nice feature is that each entry in the authentication log indicates which remote access policy applied, either to accept or reject the connection. This is a good way to identify problems with policies, because sometimes multiple policies can combine to have an effect you didn't expect. Furthermore, it is desirable in your environment. You can use the logged data to generate accounting reports to tell you things like the average utilization of your dial-in ports, the top 10 users of dial-in connect time, or how much online time accounts a certain Windows group used. Unfortunately, though, you're on your own when it comes to building tools to generate reports that will tell you whatever it is you want to know. There aren't any reporting tools included with Windows Server 2003. Monitoring ports and port activity. You can monitor port status and activity from the RRAS snap-in. The ports folder under the server contains one entry for each defined port. When you select the ports folder, you'll see a list of the ports and their current status. The list indicates whether each port is a dial-in or VPN port and whether or not it's active. You can get a quick summary of your server's workload at any time. Double-clicking an individual port displays the port status dialog box. This dialog box shows things like a port's line speed, the amount of transmitted and received data, and the network address for each protocol being carried on the port. This is a useful tool for verifying whether a port is in active use or not, and it gives you account of the number of transmission and reception errors on the report. So you can see here figure 714, the port status dialog box. Integrating RRAS with DHCP. As you briefly learned back in chapter 5, managing the dynamic host configuration protocol, each network that has a DHCP client on it must have either a DHCP server or a DHCP relay agent. Otherwise, the client has no way to reach a DHCP server and get a list. What does this mean for your remote access deployment? It depends on your network configuration as described by the following. On a small or simple network, you may choose to use static IP addressing and assign each dial-in client a fixed IP address. In this case, you don't have to fool with DHCP at all. If your RRAS server is also a DHCP server, you're okay because dial-in clients will get an IP address from that server's address pool. If your RRAS server is on a different IP network from your DHCP servers, or if you want to assign client addresses out of an address range, that's not part of any DHCP scope. You need a relay agent. The RRAS snap-in includes a DHCP relay agent that you install as an additional routing protocol. Once you install and configure it, it can tie your remote access clients to whatever DHCP infrastructure you want to use. Installing the DHCP relay agent. There are a couple of things you should know before installing a DHCP relay agent. First, you can't install the relay agent on a computer that's already acting as a DHCP server. Second, you can't install it on a system running network address translation NAT with the addressing component installed. As long as you meet these requirements, the Server 2003 implementation of RRAS will install the DHCP relay agent automatically when you first enable remote access. You can also install the DHCP relay agent manually if necessary, such as if you recently disabled the DHCP server component on your RRAS server. Configuring the DHCP relay agent. As is typical for other RRAS components, you actually configure the DHCP relay agent in two places. From the DHCP relay agent properties dialog box, and again on each individual interface. The configuration settings are required for each of these two policies are different. In the following sections, you will see how to set a DHCP relay agent's properties, how to assign the relay agent to specific interfaces, and how to set an interface's properties. Setting DHCP relay agent properties. When you select the DHCP relay agent item under the IP routing node in the RRAS snap-in and open its properties dialog box, you'll see the contents of figure 715. The only thing you can do here is to specify which DHCP servers you want this particular DHCP relay agent to forward requests. The only restriction is that the RRAS server that's running the DHCP relay agent must be able to route IP packets to the destination network. This serves the servers you specify here apply to all network interfaces to which you attach the relay agent. There's no way to configure independent forwarding addresses for individual network interfaces. So we'll just skip that exercise there, it's not relevant. Assigning the relay agent to specific interfaces. Once you've configured the list of servers to which you want DHCP requests forwarded, you still have to attach the relay agent to a particular network interface. To create a relay agent interface, right-click the DHCP relay agent item and select New Interface. When the new interface for DHCP relay agent dialog box appears, select the network interface to which you want the relay agent bound. Once you do, the interface specific properties dialog box discussed in the following section appears. Setting interface properties. Each relay agent enabled interface has its own set of properties which are exposed through the interface specific properties dialog box. The topmost control, the relay DHCP packets checkbox, lets you control whether DHCP relaying is active on this interface or not. You can turn it on or off without restarting the RRAS service. The two other controls affect how long replay DHCP requests will bounce around your network. The hop count threshold field sets the number of intervening routers between the clients and the DHCP server that the DHCP traffic can traverse, and the boot threshold second field controls how long the relay agent waits before forwarding any DHCP messages it hears. If you want to give a local DHCP server first crack at incoming requests, adjust the boot threshold up so that the local server has a chance to respond before the message is forwarded. So in exercise 7.7, you'll add a new DHCP relay agent interface for your LAN connection and then specify configuration parameters for it. In practice, you'd need to add the DHCP relay agent to whichever interface remote clients use, but because we can't assume anything about the configuration of your lab machine, this lab is simplified somewhat. So exercise 7.7. 1. Verify that the DHCP relay agent is installed. If not, refer to exercise 7.6. 2. Right-click the DHCP relay agent item and choose New Interface. 3. The new interface for DHCP relay agent dialog box appears, listing each of the interfaces to which you could attach the relay agent. Select Local Area Connection and click the OK button. 4. The interface specific properties dialog box appears. If you have a DHCP server on your local network, increase the boot threshold to 5 seconds. If you don't, decrease it to 0.5. Click the OK button. Note that the list of DHCP relay agent interfaces has been updated to reflect the new interface. Configuring RRAS or a VPN client. Dial-up RAS clients and VPN clients are very similar. Almost all of the options that are available when you set up an RAS client are the same as when you set up a VPN client. The main difference is that VPN clients specify the server's IP address and RAS clients specify the server's phone number. Also, VPN clients require an underlying connection to the internet. Client configuration is not a focus of the exam, so in this chapter, you will only see how to configure a VPN client. Just be sure to remember that the RAS client configuration is extremely similar. So the general tab of the dial-up connection properties dialog box is where you specify the IP address of the VPN server or the modem and the phone number to use with this particular connection. In this tab, as with other tabs in this dialog box, you may recognize the filled in fields when you use the network connection wizard. The general tab has a field where you enter the VPN server address or host name. In addition, the first connect group lets you specify which dial-up connection, if any, you want brought up before the VPN connection is established. With the general tab, you can do the following: change the modem this connection uses or settings for the modem you already have. With the configure button, note that you can also use the phone and modem options control panel to adjust a broader range of modem settings. Enter the VPN server address or host name or enter the phone number to dial. For RAS connections, change whether or not dialing rules. For example, I am now in the area code 770 are used when DUN decides how to dial the number for this connection. When the use dialing rules checkbox is checked, the rules button becomes active, allowing you to define new locations and edit the dialing rules attached to each. For VPN connections, specify whether or not to automatically dial another connection first and then specify the connection to dial. Change whether or not the connection shows a status progress icon in the system tray whenever the connection is active. By default, dial-up connections have the show icon in the taskbar when connected checkbox checked. The Options tab. The Options tab holds settings that control how DUN dials and redials the connection. The controls in this dialog box are segregated into two groups. The Dialing Options group holds controls that govern DUN's interface behavior when dialing, and the Redialing Options group controls whether or not and how DUN will redial if it doesn't immediately connect. Dialing options. There are 4 separate dialing options available in the Dialing Options group. The Display Progress While Connecting checkbox, checked by default, instructs DUN to keep you updated to its progress as it attempts to raise the connection. The Prompt for Name and Password, Certificate, etc. checkbox is also checked by default. When it's on, Windows 2000 will prompt you for any credentials it needs to authenticate your connection to the remote server. This may be a username, a password, a public key certificate, or some combination of the three, depending on what the remote end requires. The Include Windows Logon Domain checkbox is unchecked by default. It forces DUN to include the domain of the domain you're logged onto as part of the authentication credential. Leave this unchecked unless you're dialing into a Windows NT 2000 network that has a trust relationship with your logon domain. For RAS connections, the prompt for phone number checkbox, normally checked, tells DUN to display the phone number in the connection dialog box. This gives you a chance to edit it before dialing. You may want to uncheck it. You or your users are prone to making accidental changes. Redialing options. The settings in the Redialing Options group controls how DUN will attempt to redial the specified number if the remote end is busy or doesn't answer with a recognizable carrier tone. These settings include the following: the Redial Attempts field controls how many attempts DON will make to raise the other end before giving up. The default value is 3, but you can set any value from 0, meaning that DON won't attempt to redial to 999999999. The time between redial attempts pull-down menu controls how long DON will wait after each failed call before it tries again. Values in the pull-down menu range from 1 second all the way to 10 minutes with various increments in between. The idle time before hanging up pull-down menu lets you specify an inactivity timer. If your connection is idle for longer than the specified period, your client will terminate the call. Note that the remote end may drop the call sooner than your client depending on how it's configured. By default, this pull down menu is set to never, meaning that your client will never drop a call. If you want an inactivity timer, you can pick values ranging from 1 minute to 24 hours. The redial if line is dropped checkbox automatically redials the number if you're disconnected. The security tab. How useful you find the security tab will depend on whom you're calling. The default settings it provides will work fine for most internet service providers and corporate dial-up facilities, but Windows XP has a broad range of security settings you can change if you need to. The security options group contains controls that directly affect the security of your connection. The advanced security setting tab controls settings such as encryption and authentication protocols. Security options. The security options themselves are pretty straightforward. The security settings in effect for this connection are governed by your choice between the typical recommended settings and advanced custom settings radio buttons. Normally, it's best to stick with the typical recommended settings option and use its subordinate controls to pick a canned setting that matches your needs. These subordinate controls include the following: to validate my identity as follows. Pull down menu lets you choose among unsecured passwords, the default and the only type of authentication that most networks support. Secured passwords and smart card authentication useful only when calling another Windows 2000 or Server 2003 network. If you choose to require a secured password and automatically use my Windows logon name and password checkbox instructs DON to offer to the remote end the logon credentials you use to log onto the computer or domain. This is only useful if you're dialing into a network that has access to your domain authentication information. If you require a secure password or smart card authentication and require data encryption, checkbox allows you to have either an encrypted connection or none at all. If you check this box, your client and the remote server will attempt to negotiate a common encryption method. If they can't, perhaps because the remote end doesn't offer encryption, your client will hang up. Advanced security settings. If you select the advanced custom settings radio button and click the settings button, you'll see the advanced security settings dialog box. It controls are more complex than the ones on the security tab. The first field in the data encryption pull down menu, Windows XP offers you the opportunity to encrypt both sides of network connections using IPsec. This capability extends to dial up connections too. The pull down menu gives you the following 4 choices. No encryption allowed means that the server will drop your call if it requires encryption because you can't provide it. Optional encryption tells the client to request encryption but to contain the call if it's not available. Require encryption tells the client to request encryption and to refuse to communicate with servers that don't support it. Maximum strength encryption tells the client to only communicate with servers that offer the same strength encryption it does. For example, with this setting to force, a North American Windows Server 2003 machine running 3DES won't communicate with a French Windows XP machine because the French machine uses the weaker exportable encryption routines. The logon security group controls which authentication protocols the client can use. The default setting use extensible authentication protocol EAP is what you use if you want to use standard Windows authentication using the MD5 challenge method or certificate-based authentication using the smart card or other certificate choices in the pull-down menu. The allow these protocols radio button is followed by a long list of authentication protocols. While the specifics of how they work are different, the basic idea behind each of these protocols is the same. Provide a secure way for a client to prove its identity to a server. By selecting the appropriate checkboxes, you can make sure your client use the same protocols as the remote end. These authentication protocols include the following: PAP, SPAP, CHAP, MS CHAP version 1 and version 2. It is generally recommended that you avoid using PAP and SPAP unless you must talk to some older device that doesn't use CHAP or MS CHAP. If possible, allow only CHAP and MS CHAP version 2 on your clients and servers. By default, when you turn on the allow these protocols radio button, CHAP, MS CHAP, and MS CHAP version 2 will be enabled. This gives you the best mix of flexibility and security. So I'm going to leave it here today for this stream. Thank you for listening and have a nice evening.